Good afternoon, class. It's David, your instructor for Business Management 7250 Data Management for Analytics Professionals. This is part of Lecture 4, Part 2 of Python, focusing on data exploration and dimension reduction. This is slated for Friday, October 23, 2020. In this demonstration, we'll focus on three things. One is sampling methods. The other one is data dimension reduction. And of course, as a component of dimension reduction, we'll also be talking about correlation analysis. Just like the way how we've been doing in the past, we will do things first, and then second and third. And first, we need to import all of the libraries that we have and put it in Jupyter. And Jupyter, as you know, would be able to allow us run the programs that we have already set up. And these are the libraries, alt, enter, all of the necessary libraries are in. Next, we need to bring the data that we will be working on. And for those, we have the information in here. And there are two components. First, we need to bring the for data, and these are the invoice, the customer, the product, and the iris data. We are not going to use iris data, but since the code is already there, it's okay to bring them for whatever purpose. We bring here alt enter, and now we got all the libraries and all the data that we'll be working on. Then next we have to proceed into doing the sampling. And first, let's do about the sampling. We have said that there is non-random sampling and random sampling. Random sampling is divided into four: the simple random sampling, the stratified random sampling, cluster, and systemic. In this particular demonstration, we'll be focusing on the simple and the stratified. For both cases, we'll use some kinds of data frame. At the same time, also, we'll use the one that we'll be using for the IPC data. But I think first, then we need to merge the data that we brought, the I, the C, and the P. And we will follow the same kinds of approach that we've been doing in the past. Copy the codes that merge the three data. And when we are looking at the information, the print, we'll see all of the data that we need are already in. We have already merged them. Then let's just go to the sampling codes, which are put together in here. So data sampling, let's just do the first. Let's take a sample from ICP. ICP is the merging of invoice, customer, and product table. And to do that, we are now saying that, well, I would like to get specific number of samples. In this particular case, 3 samples from the ICP data, which has 100 observation. And I would like also to print it out. So I got row number 5, 40, and 95 are selected randomly. It could be any of the 100 ones. And if I want to check or have 10, all I have to do is just simply go in here, and the end value will be adjusted accordingly. If I need 25 out of 100, I will change that one. We can also do the same thing for the same sample, but this time around, instead of number, we can just simply get the proportion. Okay, give me 10% or 20% of the sample. So this one actually is giving us like 10% of the 100. So we should expect 10 randomly selected samples out of the 100 rows of the ICP data. So that is very important. Sometimes you might have very big data with millions of records, and if you want to get some kind of quick insight, you can take some certain samples, like 10%, 20% of that sample, do your analysis and get some kinds of quick and powerful insight. So that is where these kinds of application is helpful. But the case is that it's not always random sampling, right? You might probably have groups, and these groups would be something that you need to deal with, what we call stratified sampling. In this particular case, first we create, for demonstration purpose, a data frame, and this data frame will have this data set where, and if we are printing it actually, if we are printing this data set, it will give us like 3 1 1s, 3 2 2, 4 2 2s, 1 3, and 4 4s. So we'll say, okay, I got this data frame. I would like to sample from each of these groups, and that means my intent is like kind of stratified random sampling. So I would take this particular code and run it. When I do this, look what's happening. So I got 2 samples from each of the group. The first one used to be 3 of them, only 2 is taken. And the second one, there's like 4 2s and only 2 is taken. And the last one was 1, before it even had 1. And what this code did was just only select whatever is available. And the last one, we have like 4 initially, and at the end, it also picks those 4. So this is a way how you can just select stratified sample. It's very important, very powerful. You might have like cases where it's segmented by product, segmented by customer, and as you can see in this particular case, we'll see on ICP data, we have got gender. The data can be segmented by gender, can be segmented by product type, can also be segmented by stores. So for each one of them, you can take samples. And as we have already discussed, a stratified random sampling will be able to give us what we are looking for. Let's just demonstrate that for ICP. First, let's just bring the data in here, and so I'd like to see to get this by sample by customer ID. We know we have got about 30 samples, customers. So we'd like to pick a specific number of customers, a specific number of rows within each customer. So we did this one here. When we are looking at it, we have got 62 rows. I think it is picking up 2 because we have specified to pick 2 customers, and totally we get 62 rows. And if you look at each of the observation, we do have those fulfilled. Then we might also be interested to do some kind of, so this is a very random sampling. In this case, it's random sampling. So the other pieces, we'll just look at the columns, right? No, that was random sampling within each strata. And so we'll just look at what are the columns that we have in this particular ICP data. We know it, but it's always nice to just check it out and be aware that these are the kind of columns that we are dealing with, right? So we use just simply ICP columns, and then the column is written here, customer ID, invoice, store ID, and so on and so on. And some of them we don't really need them, right? But once we get this information, we will say just like we want to see it by customer ID, by store, by product, but it's always nice to be aware of the columns that we have. So we can run this one here and see what we get. And when we do this, we got, I think in this particular case, the selection was based on gender. So male and female. When you look at the male and female column, just like next to the age down the bottom, you have got, because we have selected five male and 5 female. So within that strata, we got a total of 10 observations representing 5 female and 5 male shoppers. So that way we got some kind of stratified sample based on gender. But if we are interested, we can also do that by whatever column that we need, by either product, by store, and so on. So once we did that, let's go to the next one, which is going to be like, you can create these 2 random samples, right? So you can modify the numbers shown in here, modify the color, modify the size of the data pointers. And if you are running this one here, you will be able to see the same stuff that we have seen. I think there is some error, and the error says data 1 was not really named as it was. Okay, this need to be fixed. I think looks like there is some kind of glitch. What I do is, I think it is likely that when I am copying it, there's some kind of stuff, but it is okay. Very, very minor, small error, and I'll take care of that one before I make it available to you. So it's just like, if I go there and do it again, let's see if maybe I was still going on there. Okay, that's fine. All what this thing would have done was to give us a graph in here. So we have got random samples for the Y, which called data 1, data 2. And maybe I think when I was labeling it, I was not labeling it in all of them correctly. There are data 1, data 2. This is very finicky. So if you make like naming, and the initial letter is capital, and but you have declared it in a small letter at the top, it always shows you some kinds of error. So that is something that you have to really watch. Like for instance, if you want to import any kind of library, the import statement have to be all in a small letter. If it is capital I import, it doesn't really work. So it is as sensitive as it is. So let's just go to the next one and see what we can get. So this is basically the same kind of run, but there's some kinds of modification. So it is like the same values that you see on the data 1, which is a Y, and simply multiplied it by a certain factor, and that particular multiplication would make it to really have strong correlation, except the magnitude or the scale will be different. And if we are running this one here, we'll be able to see the stuff that we have already seen. So that all right, let's just go to the next one. I think there's also some glitch in this one here that will be fixed, but these are just like, there are different kinds of ways that we can take random samples, and they will be able to show us, to generate these numbers and then plot them according to what we think should behave. Let's just talk about quickly on dimension reduction and correlation analysis. So we have already know how to really compute the basic statistics, because in there we'll be able to see the dispersion, the mean, and so on. So in this particular case, when we are running this code ICP.describe, it will give us this one here. But in case of also we are interested to flip-flop this one here and put the variables on the instead of on column on the row, what we can do is basically take the transpose function and implement it in there, transpose that particular value and give me a transpose value which is easy to handle and at the same time also easy to work with. So now my invoice, my promotions, my units are all on the on the row. We'll be able to see the count, the mean, the standard deviation. So I think one of the things that we need to really focus on is how is this particular column, is it very variable? Is it like only if the standard deviation is 1 or just like close to 1, that means the values in each of the observations are very much similar to each other, and that would probably be used as a way to really just like mark that column as something that do not really show quite lots of variability, and hence by extension after close examination, if it shows that everything is uniform, it can be slated for removal because it's not going to add much on the prediction of the particular kind of model. So if you are also interested to look quickly the standard deviation of the particular column, you can do that one, but the other stuff, I think the describe is much more powerful because you have got the standard deviation computed in there as well. So you can also go to the next one and see what you can get in order to computing like to see the correlation. So what we can do here first for our correlation analysis, we don't want to spoil or mess up with our data, instead copy the ICP data into what we call a modify ICP, and now we can work on this modify data. Once this happen, we are safe to go, right? And just like we did before, let's know our columns. The intent is to get rid of those columns that are character, because it's very hard to compute any kind of correlation with them. So first you can just look at the columns that you have in here and make the decision based on the knowledge of the data that you have. So quite a number of them: customer ID, invoice, store ID, all these things are something that you cannot really compute any kind of stat, right? They could be the character or just simply they are identifier. You are interested in the price, the promotion, the income, the family size. Those are really kind of measurable, quantifiable, or something that you can use for predictive purpose. So you need to clean up the data. This is a cleaning process. So during the cleaning process, you identify your columns, and then once you did that, drop those columns that you don't really need. So what you do is just simply run this particular code, and you have got very crisp data that only contains the columns that you are interested, which is going to be the ones that you can use for running your correlation analysis. And you can check it out by just printing on it, by printing it and ascertain that this is what you are really looking for. So you got all this one here: unit price, promotion 1, promotion 2, and index 1, index 2, and so on. So these are quantifiable variables for which you can compute a stat, including correlation analysis. Correlation, as we say earlier, is one way of identifying if variables are correlated, and hence are these candidates to be left or to be to be removed. So once you do this one here, you can use this particular code, which is interesting and gives you kind of a correlation heat map, but it is much more informative in terms of like what you read. So if you run this particular code, you paste it, Alt Enter, and you get this particular. You can modify the color. There is a section where the color, you can make it blue, brown, whatever. This particular information is very telling. So the one that you focus is on the diagonal and below. The diagonal and above is a mirror image of what you see the diagonal below. So when you are looking, the first like sector is just telling you that unit, of course, is perfectly related with unit itself. Price is the same way. It's perfectly positive relationship. One perfect with price is with price actually. If you look, price with price will be, see this very bright color. So the coloring is the one that indicates how much is the value. And if you want also, you can just simply focus on unit, on the column unit, and see which of the variables that you have selected has a strong kinds of correlation. I think unit, of course, has got strong correlation with negative correlation with price, as you can see in here. If it is blue, it is in the negative range, and it's kind of positive relation with promotion 1 in the area of 0.5, promotion 2 the same thing. So that means when we are promoting this product, units are selling really well. The index 1, index 2 are kind of mixed ones, but the age, income, and also on are in the negative territory. So as age increases, the unit goes down. It could also go both ways, but in this particular data, it shows that as the income goes up, unit goes down. Maybe people who have got high income don't drink lots of milk, whatever. So this way you'll be able to see just quickly how each of these variables related to each other, and based on what you see in here, you would have first a couple of things. One is how related to each other and which one to eliminate and which one to keep. Second, how to proceed further in terms of like establishing relationship and analyzing, doing predictive modeling. If you want to do any kind of forecasting, on kind of optimization, and any kinds of elasticity estimation, all those kinds of stuff, this one gives you a guidance, a quick and dirty way of really just like having your decision-making process improved. So definitely something to really leverage going forward. So I think this is what I have in addition to this one. There's also another one very, very quick and at the same time also powerful, right? The Seaborn. You can write just simple Seaborn here, as shown in here, and go to Jupyter and run it. You'll get quite lots of stuff coming to you. And when this happens, it takes a little bit of time because it's already processing quite lots of information there to present it into a graphical format. And what it shows is a graphical form of relationship among different variables. Pretty much what we see in this heat map, but in the particular Seaborn case is much more detailed. It's very graphical. So it shows like particular, here is like the first one is how price is related to, let me just enlarge it. I think I can. Yeah, so the first one is how, second one is how it's related with price. Let me just go to the PowerPoint and enlarge it. Perhaps if I did that, I can see things clearly, because they are very fine in terms of like size, very hard to see clearly. I can enlarge it again. So yeah, so what you see in here is that how unit is related with price, and so on. Here is how unit is related with itself, unit with price. As price goes high, unit goes down. And this is a promotion one. Promotion are either 1 or 0. 1 means the flag is raised and there is promotion. So you'll see quite lots of sales happening when promotion is raised compared to the other one. I am in Jupiter. Okay, here this is better. And then the list goes on. So here is also how that related to with index 1, index 2, and so on. So this is really just like a very quick and dirty way of knowing the heat map. So in general, this is all I have, and we can really expand on this one here. When you go to the next one, we can use this sampling technique for simulation. I haven't really included into this one here. Last time we have touched base a little bit of it, but we can expand next time around. But including the lecture that we had and this demonstration will give you a very good sense of how we can really use some techniques to reduce the dimension of data and improve our prediction process. So I have for today, and thank you, and have a good night. And I'll see you tomorrow. So I think most of you will be coming. Some of you may not be coming because of various reasons, but we'll definitely have some kind of Zoom connection, and we'll have very nice discussion. Take care and good night.